Okay, we're still on functions, and I'm hoping that you remember what a function is again. So if you're not really clear on what a function is, this time we will get into it. Okay, so we're really going to define what this is this time. Now in part 4, we're going to still use our domain, range, and then this guy right here. That's the one that we haven't really touched on, and that's kind of what we're building on. So remember our domain? We haven't really touched a lot of it, but just remember, as it's coming up, it's all your x values. So you can remember that this is pretty much your x values. This is pretty much all your x values. Okay? The range, remember, this is your y values. And if you don't know what values are, think about the x-axes and think about the y-axes. If you don't remember what those are. But one thing I want to really pay attention to this time is this guy right here. And I want you to we're going to call this something. It's called a function notation or function equation. So f is our function. That's what that f is. So the x is going to be what we call our inputs. So I'm actually going to put this up here. So up here, this is kind of what we're doing. So this here is what we're going to put inputs in. So what I'm trying to show you is that our inputs are going to be in here. These are all of our inputs. Okay? This here is what we call our outputs. So if we put an input in here, something happens and we get an output. So I'm going to draw a little picture of this, and maybe this will clarify a little things maybe. So we have a funnel, like a funnel. And we have our little, like a box or a system. And say that this system, it processes something and you get something out of it. You've probably seen this before, I don't know, but many teachers draw this and maybe it helps to those visual people. But really, what we're doing is that we're putting all of our inputs in here. So all of our inputs. So maybe you throw an input, you put a 1, you put a 3, you put a pi into the funnel. It gets down and then something gets processed in here. And this is where the f of x comes. So let's call this then. So our funnel, we get our inputs. Our inputs get inputted here. It gets into the system, and I want you to call this. F of x. Sorry, this is called f of x. This is called f of something. F of x. So whenever you see this, whenever you see something like this, it says f of something. Doesn't always have to be f. It could be g. It can be h. It can be anything. It can be anything. But really, this is what we call the functions. This is our function. This is what we call the function of something coming out of it. So you put something in, the function works its magic. And then you get what we call an output, which is what we call our what? Our y. So you put something in, the function is its gears are turning, it's being smashed, it's working the thing that you put into it, and something comes out of it. So let's say you have a car, you put some aluminum, maybe some raw aluminum, into the machine processes it, and here comes out a frame of a car, or a door of a car, or maybe you put some wood shavings from like a tree, and then you come out with a pencil. So something like that. So this function, f of x, is really what we call our function. And that's kind of what we're doing with this here. You're putting something into the machine, it's working, you get something out of the machine. Now, is there a time that you can put in two things and get the same thing out? So for example, I put a quarter in, I put a penny in, and something comes out. Technically, you can't have the same output for the same two inputs. And that's what we're getting into. So to note this, you can't have the same inputs, the two same inputs, give you one same output. It doesn't work. And that's what we call a non-function. But let's work on this notation and build onto it. Okay? So I'm going to still use it, but let's go into this a little bit. So remember, your input, your output comes out. Okay, so let's do this. Let's save that, because that's important. Okay, so let's bring this to our more of attention. So let's say, for example, example 1. I want you to make a T-chart. Remember what a T-table is, or a T-chart? Remember that in the first beginning, that's part 1, it was a T-value, or T-table. It looks like something like that. And remember, this was the X's, and this was the what? The Y's, right? But remember, we're not going to call it the Y's really much anymore. We're going to call it the f of x. And you're going to be thinking, wait a minute, that's supposed to be the Y's. Well, technically, this is the Y. This is your output. Because now we're using a function notation, or an f of x. This is going to be our output. So, what if I gave you something like looks like this? This is number 1, example 1. What if I gave you something like that? And you'd be like, well, I really never saw that before. And that's okay. What does the 3 mean? The 3 means it's your remember that? The rate of change? What we did from this formula here? That's that. So maybe I gave you 2 points already. Maybe I gave you 2 points, and now I calculated our rate of change to be 3. Okay. So I did the hard work for you. I gave you the rate this time. We didn't have to calculate it by 2 points. So, here we go. Oh, by the way, this is times our rate times our input. And for visual people, let me do this for you. And let me do this for our visual. You know, I'm a very visual person as well. Just to help you out. That color might help you out. So let me ask you something. What if I gave you a number? What if I gave you 0 for our input? What do we do with it? Yeah, we're done. No, we're not done. I gave you something 0. You're going to take this and you're going to put it in here. So you're going to do something like this. Okay. What is 3 times 0? 3 times 0 is 0. Okay. Let's do another one. Put 1 in. What's 3 times 1? Let's do some more. What's 3 times 2? Do some more. Put 10 in. What's 3 times 10? Do you see something that's going on? What are we always using? We're always using our rate. Maybe it was on part 2 we used, maybe it was part 1 actually, $5 or $10 an hour. Well, that's what we're always using. We're always using that 10 or 3 or a number in front. We're always using our rate that we have. And what we're doing, we're just putting in inputs to see what we get from our output. So that's pretty much what we're doing. I'm giving you an equation and I'm giving you some values and you just give me the output of that value, of that. And that's pretty much what we're doing. I'm giving you something that, I'm giving you an equation, I'm giving you some inputs, and now you give me some outputs by doing some calculations, but always multiplying by 3 in this case. And that's pretty much what we're doing. Let's do some more. So I'm going to erase this, but I'm going to use some of it. So you might want to erase or start something new, or write it all again. So here we go. I might use the same numbers again, so you can just do that, hold out on that. But this is all going to change. Okay? So this is example 2. You might have to stop this video and redo this. This is number 2. This time, let's do something with a little bit more arithmetic into it, more problems. So what if I gave you the equation that looks like this? if I gave you something that looks like that? You might need to shift this over. So real quick, just to make this bigger, you shift this over. This is always your y. Okay. So this is your equation. 2x minus 10. So let's think about this in a real life thing. My rate is what? 2. My rate is always 2. So I'm always going to multiply by 2. Right? Because this is multiplication. But after I multiply by 2, what am I doing? Subtracting 10, right? So real life, students are always asking me about real life and how does it relate. Let's say, for example, I borrow money. I want to open my own business. And I go to the bank or some person and I borrow some money. Well, aren't you going to be in debt? So let's say you borrow, side note, let's say you borrow $1 million. So here's my equation. And I borrow $1 million. So that means I'm in debt $1 million. And let's say I work out something with the bank. Okay, every month I want you to pay back $1,000. Every month, pay back $1,000. So $1,000 times my x. So for every month, I put $1,000 in, but guess what? You're still in debt because you are still owing money. So for every $1,000 for every month, you still have that million to pay, and you're paying. And we're seeing, I'm hoping you're seeing, that this is actually doing this. It's a straight line going up. And you're gonna realize after how many months will I be debt free? I don't have to owe that $1 million anymore. And that's kind of what this is also used for, to kind of gauge to see when I can be free of debt of that $1 million that I borrowed for my business. Okay? So let's do this one. That's why I like these kinds of equations, because it can kind of really relate to a lot of real life aspect. Okay, put some values in. What if I gave you, so we have 0, 1, 2, and 10. Okay, we have these values that we put in. We're just going to leave those. Now what? So now we're going to go always 2 minus 10. Always 2 minus 10. Always 2 minus 10. Always 2 minus 10. Remember, we're always keeping our rate, and we'll always have to subtract 10 from our value. So, what do we put in here now? What do we put in for here? 0, 1, 2, and 10, right? Now what? PIMDAS. 2 times 0? 0 minus 10? Minus 10. 2 times 1? 2 minus 10. Let's see, that's 2 minus 10. What's 2 minus 10? Negative 8, right? 2 times 1. Sorry, we did that one. 2 times 2, 4, minus 10. 2 times 10, 20, minus 10. 4 minus 10 is negative 6. 20 minus 10 is, ooh, positive 10. Those are your outputs. But I want you to see something before we do this. Do some more. You see how these are negative? You see how these two are negative? How these two are negative, and guess what this one is? Positive, right? So something happened right here. So something happened to make it positive. After how many months makes your income positive, where that debt is gone? Okay. All right. We're going to do some more with this. So hopefully you understand what we did here. I'm hoping that you got this f of x, or f of this function notation, or f of x. And I will see you in the next one.